Hello and welcome everyone. So I'll be explaining you this number C problem, code forces round 694 div 2, problem named Strange Birthday Party. This problem was easy to me, actually easier than B it took me because I did a very silly mistake in problem B. So I'll explain you what actually the statement says. So the statement says actually something like, so you are given, okay, so he organized a strange birthday party. He invited n friends and assigned an integer ki to the ith of them. This ki actually is the um, okay, so in the nearby shop, well, I will always have what, m unique presents available, and the j present costs of cj dollars. And now you have to you have to observe this portion here, this array, the present array, the m unique presence array, their costs values, this array is actually initially increasing. So you don't need to sort this array because okay, and then because it is already sorted now, it's not allowed to buy a single present more than once. So you cannot allow to buy cannot be allowed to buy a single present more than once. Now for D, now you have two choices. Okay, you have two choices. Either you can buy the J present, either you can buy uh, the K ith member, I mean the ith friend. Either you can buy the ith friend uh, a present which is less than or equal to uh, a present index of j less than or equal to ki, which consists of cj dollars, or if you see or you could just give them just the money, not if the presents are not available, or if you sense that this might give more cost or something like that, then you could also give them c of k of I dollars, which means the dollar for that particular gift. That's just the dollar, not the gift. So you have to determine the minimum total cost of hosting his party. Okay, so you have to minimize the total cost of hosting his party. I will explain you one example here. Remember one thing here: n and m are not equal. Okay, n and m are not equal. You have to maintain that too. Okay, they won't be equal, and that's exactly why. Also one thing to notice here: this array k there can be multiple same values, but they all will be in between 1 and m. Okay, so let's take this example. This is a very good example to understand this problem. 2 3 4. Okay, we're given what, an array of 3 5 12 20, 3 5 12 and 20, and 2 3 4 2 3 4 3 2. Now first of all, this is your friend. Okay, this is the number of your friend, this is your friend's array, and this is the price, the gift's price actually. So you could denote it as C, let's denote it as A, and let's denote it as B array. Okay, now this is the gift array and it is already sorted. This is the price of it. You need to minimize the total price. You have to give each of them at least something, either the gift itself, which will gonna cost some money, or the money itself. So you need to determine what the minimum cost. Okay, but you need to make sure you give each and every one something, money or gift. Now the primary observation is here. Look, we are given this value, and look, this index, I mean the my friend's index, this value, what does this value represent actually? These values actually represent the indexes of this gift. Okay, this value represents this. Okay, so as this value is sorted, we need minimize. We need to print the minimum cost, right? So you will always want someone where he is where his gift value, if his gift values, if you could somehow optimize someone's gift value, uh, I mean if you could some if you could somehow optimize someone's gift value, you could make it, you could actually do that, because look here, the array a value is actually representing the indexes of the gift, and we also know that the more the index, the bigger the price. So an optimal way to do that would be to making the array a, which means the friends array, we're going to be sorting it. Look, why I'm sorting it, I will explain you once again. If I sort this, look, 2 3 uh, 2 I'm sorry 2 2, okay, 2 2 3 3, and also what, 4, 2 2 3 3 4. This is the sorted portion. I'll sort the friends array. What does the friends array's value represent? It represents the indexes of the gifts, and we also know the more the index, the greater the price, so we don't want that, right? So what should be the right approach? We will start from here. Yes, that's exactly. We'll sort the friends array and we will start from the last one, because we know if the last one will definitely represent the greater index, and that greater index will be of greater price. Now what we actually going to do, we're going to be maintaining two pointers. One pointer will represent the last element of my array B A, and the other pointer will represent the first pointer, the first value of the gift. Okay, why I'm doing this? Look, here this condition is going to help us. This condition says that either you could give them the present, a present of index j which is less than or equal to ki. Exactly, that's exactly what you're doing. You were making sure that this j is as small as possible and this ki is as large as possible. Isn't it what I'm doing? I'm maintaining one pointer to the rightmost, which is the friends one, and the gifts array to the gifts costs array to the leftmost, which is maintaining this. So you will, what you will do, you will make this j as small as possible and this ki as large as possible. There can only be one way to make sure that sorting the friends array, because and the gifts array is already sorted. They have given us sorted. So so the general assumption is, okay, we're maintaining this as the right pointer and this as the left pointer, and now we can check. Okay, we could actually maintain a loop. I'll show you in the code part how we did that. Actually it is here, I think. I hope so. Where was the code? So this is the code part. I'll show you where I'm doing this. So I'm taking n and m, right? And then this is just I'm just taking one indexing. That's why I'm just initializing. That's not, none of it matters. Okay, so I'm taking this value and I'm initializing a tracker, which means which of the friends' work has been done yet, or, and just for that reason I'm just making a track here, and I'm taking the value b and also the value of a. Now I've already told you that the array of b, which means the gifts array, is already sorted and the array a is not sorted. That's why we're going to be sorting this This is one base indexing, that's why n plus 1. And as I've told you, I will make a right pointer and a left pointer. Right pointer is pointing to n, which is the last friends index actually. Uh, Actually, not the friend which has the index of the last possible gifts. That's exactly what is maintaining. Now we're going to be maintaining a while loop. Inside that while loop, I'll be giving two conditions. Now you have to understand what are the two conditions. Here, look, the first condition is what I'm doing. While I is less than or equal to aj, I is less than or equal to aj, and that's exactly. Look here, I is less than or equal to aj. That's I'll show you. Okay, I is less than or equal to aj is similarly equivalent to this portion. Okay, this has to be maintained every time you do. So this has to be maintained. If this loop breaks, if somehow for some index this loop breaks, which means there are no indexes left that you can apply, then the rest of them you have to give them their money instead of the gifts. That's exactly what has been maintaining here. So inside that while loop, I am maintaining two things. One is I is less than or equal to aj, and also I is less than or equal to m. Because why is that? Because n and m are not equal, so I have to maintain that. Also, I have to maintain whether j does not get out of bounds. So I and j, if they're as they uh, as they don't uh, go out of bounds, that's why I'm doing this. But this portion I have already told you, this is the just a condition that we already met. Because if that does not satisfy, because I'm doing this from the rightmost and the leftmost two pointer containing, and if this condition does not apply, then the all that indexes are left are actually the ones whom you will have to give money instead of the gifts. And that's exactly what I'm doing. Also here, m of j minus minus is actually tracking which of them has been given the money, which is the lesser money. uh, and I'm just tracking out those values who has already uh, completed that their whom I've already given their gifts. And finally we're just traversing one loop to find out whether he has been given or not, whether he has been given his money or gift or not. If not gift, then I'm just giving just the money. Look, this b of a of I is actually referring to this c of k of I. Okay, because at the end of the array, when all the gifts are empty, I mean there are no values in there, then the ones who are left, you will just have to give them their this c of k of I dollars, right, directly. That's all you have to do at the end of it. That's how you're going to be maintaining the minimum cost. So I hope you like these. I hope I made you understand. And until next time, goodbye. I'm sorry for not explaining that great. That So till next time, goodbye. Okay, so.